In my last video, I did a presentation on making this router jig for cutting arcs and circles. It's complete, turned out very well. So today, I thought I'd show you what all of this is about and to what use this is going to be put. I made that router jig so that I could rebuild these lower trunnions for my fingerboard arching jig. Uh, because of the problems I was having with the platen and its movement, I changed support mechanisms, of course, and that required the whole thing to come up in the air off the bench. So the lower trunnions had to be redone. Fortunately, the upper trunnions were good. I didn't have to rebuild all of that. But I brought you to the finished end here early in the video so that you could see in general what it is I was really aiming at and what we ended up with to get the job done. So the video will contain several segments regarding fabrication, and then toward the end, I'm going to take the time to bore you half to death, probably, with a little bit of dissertation again on making tools and some of the philosophy involved in that. So now I have my router jig set up on this plywood panel. And you can see here the arc that it will cut. This panel is going to be used now as a fixture to register every workpiece that needs to go on it. Each workpiece will be registered on this and positioned and held down so that the router can cut that finished arc as you see right there. That's for the purpose of rebuilding these lower trunnions. The lower trunnions need to be rebuilt because they will not sit over the new mechanism that will amount to the new replacement carriage. The upper trunnions I found I really don't have to rebuild them. There's no need to. And these are nicely made at the correct radius, so there's no need to go there. But we'll progress through this and I'll show you some of the steps along the way, and then eventually we'll get to the finished device. I have a tendency to be a lot more concrete operational than formal operational, so it's easier for me to design things quite frequently by manipulating objects. And so I got this equipment out. This is what I'm going to use for the track in this device. These are Thompson linear motion rods and they're compatible bearings. These are really neat. Those are recirculating ball bearings in there. These things hold up really well and they're nice and tight. They move smoothly. These were originally used in equipment that was used to place electronic components on circuit boards. So from there, getting the idea of what it was I wanted to do, I then made a drawing. And the drawing was really stupid simple to make because I just literally stood the equipment on end and traced it out quickly. And it gave me a quick, easy way to figure out what I have to do. The purpose being to arrive at the exact shape of this trunnion piece right here. So that'll be the first thing that I'm going to fabricate. While I'm waiting for the glue to dry for those trunnion blanks, I started by making up the traveler. And my traveler platen is going to be, this is cherry, and it happens to be 2 layers of material and each one laid up in 4 layers. So got kind of a butcher block thing going there for stability. And here's my Thompson bearings. I've positioned those on the traveler where they need to be to allow me the proper distance that this thing will run. And I have very carefully positioned everything, and I have that clamped down. So now I'm going to spot those holes and mount those. Well, here's the traveler. Nothing too complicated about this. It's drilled on the bottom for all of those guide blocks. But I thought it was important to varnish this, and I'll varnish this 2 or 3 coats on both sides, all 6 sides in fact, because stability is important. And on this surface we're going to be putting double face tape on there periodically, so we'll want to have a surface that can be cleaned off with naphtha and we can go again. Having the travelers done, now I've turned my attention to the trunnion pieces. These 2 blanks that'll form those trunnions are sized, thickness, and so on. And what I've done on this staging piece of plywood that I showed you before is set up this rail, a fence, so to speak, that's perpendicular to a center line here, and it stops the blank in the right place for the top of the arc. And according to a center line on the blank, I've positioned a stop right here so that both blanks fit in. So the first thing, I'm not going to try and route this directly. It's just a lot of hogging with the router that's unnecessary. I will set up my trammel and I'll mark that out and I'll rough it out on the bandsaw, and then the router here will come back to the stage and cut this thing out. I have my router in position ready to swing an arc, and I have my blank registered, or at least close. There it is. Um, but it's not going to stay put. As you can see, it moves too easily. And given the amount of work to do this in the first place, I'm not going to trust a couple of pieces of double-faced tape. I probably could, but I'm not going to. I'm going to screw these blanks down, and I'm going to take advantage of this waste area right here. This is all going to be cut away. So I'm going to screw that down. So I've got my drill press set up to drill these just 2 holes in this waste area. But I've taken the time, it's not much time, but I took the time to jig this up a little bit. I've got a rail and a stop here, and I've done that simply so that I can assure that I'm within the limits of where I need to be, within the waste area, but also so that the drilled holes will be in the same place in both blanks, which means the mounting holes in the plywood will be in the same place, and it'll just be much easier to put these parts in there and get the work done. Now, I'm going to mount these with these square drive cap screws, the Craig screws, you know. And these are self-drilling, self-tapping, and all of that stuff, but not where precision mounting or registration is concerned. If there's any movement, you lose it right there and you got to drill all over again. So I'm going to jig this up, and I'm drilling a hole that is just oversized for that screw. I'm drilling a 3/16 hole that gives me just a little bit of wiggle room so that when I set this down, I can make sure it's registered and then tighten the screw down and we'll be in position. So now I'm ready to strike a rough arc on these blanks and hand bandsaw those out reasonably close. And I want to strike that arc using this. I'm sure many of you are aware of these or own them. This is a set of trammel points. And this one, I love this tool. This was my father's, so it's been around for decades and decades and decades. This is an LS Starrett. Look at the beautiful chrome or the polished finish on that. Has this pencil option and another point like this you can put in it. Just a beautiful tool. And I've got this rigged up so that I can take advantage of my registration hole down here, my center pin. So it's, you know, this part's not rocket science. Just going to swing an arc on there and then take these over to the bandsaw and rough them out. Well, we're about ready to route one of these things. I already did one, and confession, something I forgot. I had to counterbore these mounting holes because the router won't pass over those screw heads, of course. And I counterbored them because these are essentially a pan head screw. And I would warn anybody that countersinking a mounting hole for something that needs to be precise can be very precarious because countersinks are often not dependable, especially in wood, and they can throw off your mounting. So anytime you can counterbore and use a pan head screw, you're better off. You also get a little bit of adjustability. So the router's in position. I'm working counterclockwise across this. Because I don't want the router to pull its way into the work. It would be very hard to resist that. So I think we're ready to go. Put your ear protection on here, and we'll do one. So a lot of trouble has been gone to do this operation. First, making the routing jig, which I made multi-purpose because it's so much work to make it up in the first place. There was no point in making it a single purpose tool. Um, but then the stage that all of this works on, the rails and the stops and all of the other stuff that goes with it, it is a lot of work. But the result is right here. These two trunnions are exactly the same. And these trunnions are equally as important as the traveler that will ride underneath them. So every bit of care that can be taken to ensure precision is worth the time and effort invested in doing it. Well, I got to create these openings for the traveler to pass through, and I could cut them out with a bandsaw neatly and leave it at that, but instead I cut them out rough, and I'm going to refine those with a plunge router and this quick jig that I just made. Necessary? No. Fun? Yes. All right, I've got the trunnions assembled, at least rough assembled and lined up, and I've got a base ready for that to be mounted to. And over here, I've got the traveler mounted on its bearing blocks, and the rods are running smoothly. Everything's looking good. Next step will be to finish up the trunnions, mounting these little guide pieces here inside to keep the whole thing from running on track. And I got to make 6 of these guys. These rest underneath and support the rods, and they don't interfere with the bearings. They travel right through. So I got to make 6 of these, and they've got to be made up about like this one here. So a lot more work to do, but we'll continue. Well, the woodwork is pretty well done, and I've got some varnish on some of it waiting for it to dry. So the next step is to make, I'm going to make 4 of these blocks. This is a rail that has a little groove milled in it here, made to support those linear motion rods. And the rods are pre-drilled and tapped, but I'm going to have to do the drilling and tapping, or the drilling at least, in all of these, because even though this stuff comes in 3-foot lengths or 2-foot lengths, it's pretty expensive, and it's easier and just as good to make 4 separate blocks. So there's a sample of a cherry fingerboard. It's just scrap wood that I just machined. You could see that happen. And I'm getting a real nice 16-inch radius out of it. I'm real happy with the results of this. I thought I'd take this opportunity to point out that the bit that I'm using this is a common 1/2-inch shank dish cutter bit. We're not focusing very well, are we? That's a dish cutter bit, and I find that that works best because if you can see the edge of that, that edge is rounded. There's a radius on that, and that works out real well because it doesn't tend to chip quite as much. So I found that seems to work best. The trouble is those have a short shank, so I've had to use a router extension on that, and you got to be careful with those because some of them are real good and some of them flop like crazy. They're just not concentric at all, so you have to be careful with those. So there's the finished device, and there's a sample of a fingerboard. I'm very happy with it. I'm getting good consistent, thickness and a proper arch. So I'm happy. I'm going to call this jig successful. But I want to spend a few minutes talking about making tooling, which I have done before, I know. Uh, Once again, I'll reiterate that I want everyone who fabricates anything, it doesn't matter whether it's guitars or furniture or leather work or copper or whatever you do, Um, I want you to make your own tooling as much as you can, because one of the things that I know from my own experience is that by making your own tooling, uh, you are then the architect of everything you do, from the very beginning of what you do in your shop to the completion of the end product that you're trying to make. You can more easily manipulate your processes and your outcomes. You can adjust what you're doing. You can redesign and retool and refabricate to make all of those things happen. And it makes a better fabricator, a better craftsperson out of anyone who engages in it. Now, I know some of you, excuse me, may be thinking that you don't possess an awful lot of skill at this stage of the game. And that's okay. You start where you are, because practice and making your own tools and patterns and things, you'll get better at that too. At the same time, you'll get better at fabricating what you do. Lastly, I want to talk about hardware and components. I did a video earlier where I talked a little bit about that stuff, and I showed everyone, piles of scrap metal and junk and components that I've saved around here. And I think that's all a good thing to do too. I know sometimes you have a spouse that uh, maybe they don't care for that stuff. Well, you got to compromise that out. I don't have any answers there for you, but if you can, save some of that stuff for your use. Um, but more importantly, uh, it's not easy to get scrap metal the way it was, and it's not easy to get machine components and pieces, because that stuff has gained value in the last 30, 40 years, and they don't throw it away or give it away. They sell it as scrap, and it's become valuable. So what do? Well, you do the best you can. That's what I do. It's hard to get stuff, but you manage a little bit, trickles here and there. Um, but more importantly, use the materials that you do have available, but design your jigs and your fixtures and all of your tooling as much as you can by using common hardware and common components and little devices that you can buy in any hardware store or any of the big box stores that are all around us. And you'd be surprised how much stuff there is. If you look in their specialty parts drawers, you'd be amazed at the number of bearings and bushings and specialized fasteners and doodads. There's just a plethora of that stuff out there, and it can all be put to use. And you'll also find, in their small metals racks, there's all kinds of metal pieces and aluminum and rods and thread rod. But also, I find if you search around areas where they sell, for example, sliding door components, garage door components and fixtures, and so on, there's a lot of things out there that you can use. Sometimes it's fun just to walk around one of those places and sort of take an inventory for yourself and look at what you might be able to do. And it's like detective work. You don't know what you're looking for, but when you see it, you know that you found it. Um, so anyway, uh, make tooling as much as you can. And I want to encourage you, even if you don't have the equipment that I happen to possess, it doesn't matter. You work within the technology that you have, and you can still make yourself some really good and very useful, valuable tooling and things that you cannot just go out and buy. So there you have it. Thanks for listening to my soapbox dissertation. This is Kevin Ledoux, the Pragmatic Luther again. Um, Still making guitars here in the town of Triangle, and still the largest fabricator of musical instruments, period, in the entire town of Triangle, New York. So until I produce another video, thanks for watching this one. Subscribe if you haven't. Put a like on the video if you haven't. I'd sure appreciate it. See you next time.